This is again a short video which is basically on data compression. This form of compression can be used for both data compression as well as a form of hashing also, since it somewhat ideally suits that purpose, basically ordered hashing. Now we know that the objective here again is to map a number which is n, which is less than m equal to 2 power n dash to a value b which is less than s equal to 2 power l. Basically, we want to perform the mapping from m to s, that is 2 power l dash to 2 power l, where l dash is much larger than l. Now we know that the ratios associated with the bits of L dash are basically 1 by 2, 1 by 4, 1 by 8 and so on up to 1 by 2 power L dash. Now suppose L dash by L equal to n. Suppose L dash by L is equal to n. That means now the ratios associated ideally would be just here, but here it will only be, it will be the same thing only, 1 by 2, 1 by 4, 1 by 8, 1 by 2 power l, and but L dash by L is ratio is n. So what we do is, if we want to do this, the simple way to do this, which should offer very good what we notice here is 1 by 2 minus 1 by 4 equal to 1 by 4. 1 by 4 minus 1 by 8 is again 1 by 8 and so on. So if you have a weight here, Wi plus 1 minus Wi is equal to Wi itself. This is the invariant condition that we must maintain. So what happens is, now what we can do is, we can skip over n minus 1 weights and add them like this, and perform that for the L weights, add the weights together, n weights of those. In this way, you should get decent compression, and the least value will not be too large also. So the smallest value, and this ratio would also be preserved. Thus we will have here 1 by 2, 1 by plus 1 by 2 power n, one by n plus 1, sorry, plus 1 by 2 power 2n plus 1 and so on up to, this will be the least weight, plus 1 by 2 power n into n minus 1 plus 1. So this will be the leftmost weight. The next weight will be one by 4 plus 1 by 2 power n plus 2 as a ratio, comma 1 by 2 power 2n plus 2 and so on, plus 1 by 2 power 2 into n minus 1 plus 1. Okay, then 2 into n minus 1 plus 2 and so on. So this is how we do it. Then what happens after you take off n of these, assign n of these to LM? Then what you should do is, for the last one, you should go back and start with the first weight of the previous one. After n of these such assignments out of L, after you have made just n of these assignments as a ratio, when you come to this, now here you will notice that all the ratios differ from each other by half. However, the numerator, the leading weight itself will not be half, slightly less than half it will be. So you will have to scale up n by the difference between that. So the sum will not add up to 1, it will add up to slightly less than 1. The ratio, so you will have to scale up the key that you are coding by that amount, which will, I suspect, will only be the difference in the last weight. Okay, so let me take a simple case here and illustrate it with an example. Suppose I have 6 bits here. I wish to hash 24 bits to 6 bits. Okay, a hash or distribute the weights in this fashion. So now we have a ratio of 4 here. So what you have to do is, you start with 1 by 2, the weights will be 1 by 2 plus 1 by 2 power 5 plus 1 by 2 power 9 plus 1 by 2 power 13. This is the first one. The second one will be 1 by 4 plus 1 by 2 power 6 plus 1 by 2 power 10 plus 1 by 2 power 14. The next one will be 1 by 8 plus 1 by 2 power 7 plus 1 by 2 power 11 plus 1 by 2 power 15. And the next one will be 1 by 4 will be 1 by 2 power 2. 8 will be 1 by 2 power 3. 1 by 2 power 4, comma 1 by plus 1 by 2 power 8 plus 1 by 2 power 12 plus 1 by 2 power 16. Okay. So, and the next one will be 1 by 2 power. Now what you should do is, for the next one, this is the fifth one, what you should do now is, you cannot afford to take here 1 by 2 power 17 the next way, because then the ratio will be half will not preserve this, the invariant will not be preserved. So what you should do is, you should start off with this one, 1 by 2 power 5. So you should start off with 1 by 2 power 5 plus 1 by 2 power 9 plus 1 by 2 power 13 plus 1 by 2 power 17. And finally the last weight will be one by 2 power 6 plus 1 by 2 power 10 plus 1 by 2 power 14 plus 1 by 2 power 18. So as you can see, for the value of the key, the last value ratio will be 1 by 2 power 24. However, we are getting 1 by 2 power 18 as the last ratio. If the ratio n is there, even then it will be slightly more only difference will be only slightly more, close to s only, value of s only. So s to l, again close to l dash, close to l square only, or quadratic ratio only we get. This form of hashing can be done both for data compression as well as for ordered data compression as well as for hashing into table, because now you can see that 24, 18 means 2 power 6 difference only is there. Your bucket size can afford to be 2 power 6. Okay. So now what do these weights add up to? So the numerator will always be 2 power 8 plus 2 power 4 plus 1. Okay. And then you will have, firstly, the first one will be, this is the first one, sorry, 2 power 13. Okay. So basically, if we look at it this way, the first weight will be 2, all of them will have the same numerator, 2 power 8 plus 2 power 4 plus 1 by 2 power 13. As you can see, this is not 2 power 8 by 2 power 13, is slightly less than 1 by 8 of it. So that means you will have to scale up the key, that's all. It's a small this thing. The next one will be 2 power 8 plus 2 power 4 plus 1 by 2 power 14. The next one will be 2 power 8 plus 2 power 4 plus 1 by 2 power 15. Then next one will be 2 power 8 plus 2 power 4 plus 1 by 2 power 16. Next one will be 2 power 8 plus 2 power 4 plus 4 of these, right? Plus 2 power 1 by 2 power 17. And the last one will be 2 power 8 plus 2 power 18. So these are the 6 weights that you should assign. Here only the value will be slightly less than half, for which you'll have to scale up the key a little. That's okay, because smaller values have very less probability of occurring also. So leading all zeros and all may not occur. So this form that most complex problems have very simple solutions, which are really very, very effective. You should try to aim for those kind of solutions. Okay, this is a practical way of doing it. So this gives you something like by 2 power 18. So this value will be 256 plus 16 plus 1. Basically 2 power 7 by that's 273 by 2 power 13. 8192. That's the first value. 273 will remain the same for all the other weights also, all the other ratios also. But the last one will be 2 power 1 by 2 power 18. Okay, so instead of so this way you can try to redistribute the weights.